Hello everyone. So today I want us to discuss just a little bit about process control. Process control. Right. So why do you even need to do process control? So remember, when you design processes, you usually design them in steady state. A steady state, right? A steady state. You assume steady state for the processes from the design phase, right? Meaning that you remove the time factor from your equations, right? Usually you're going to remove the time factor from your equations. However, processes are dynamic. Meaning that even if you assume steady state, processes do not just exist in steady state. There's gonna be disturbances. In your process. There's gonna be disturbances. So this disturbances is gonna disrupt the steady state. So the systems are gonna become unsteady. So you ideally want them to be at steady state. You design them so that they can be at steady state. However, there's gonna be disturbances in your process. As a result, your processes are gonna become unsteady. So you do process control so that the processes that you design can go back to its steady state. Okay, I want to emphasize this concept of Laplace transform. This is the concept of Laplace transform. This is very important, especially if you want to understand this whole thing of process control from the fundamentals. Right, because remember, when you do a model for process control, you're going to find that you end up with what you call differential equations. Right, could be partial differential equations, like stuff like that. So you have to find a way to change from time domain into Laplace domain or the S domain, right? So this is the T domain. And then you have to find, after finding Laplace domain, you're going to invert back to the time domain. But now you have an equation that is a little bit easier when it comes to its application. So what I want us to do now is to start this thing from the fundamentals, right? You need to understand that if you have an equation f of t and you want to convert it into f of s, into the Laplace domain, right? You have an equation that tells you that the Laplace transform of f of t is equals to the integral f of t e to the power negative s of t dt, right? So we're going to try to find what would be the Laplace transform if f of t was equals to e a of t. The reason I want us to study here is because most of the differential equations that you find, they end up into this form. They're usually going to have this exponential part of it. So you need to find, now we're going to establish what will be the Laplace transform of this, so that we know what will be the inverse transform if we find ourselves with this when we are solving our differential equations, right? So let's see. The Laplace transform of e a of t is equals to 0 infinity e a of t. So basically that f of t I just substituted here. Right, I just substituted there this thing, and then you end up with e of t e negative s of t dt, right? So this becomes your normal integration. So now you have e a minus s t dt. We know that to integrate this is going to become e a minus s t over a minus s. You know from your integration rules from first year, second year. Then this is 0 to infinity, right? So now you're going to substitute your limits. Your first limit is the infinity. So you have e a minus s infinity over a minus s minus e a minus s 0 over a minus s, right? So here you have to establish a certain condition that's going to make sure that this thing converges. So if a is what? If a is less than s, then this whole thing is going to become negative. And then if you raise anything to the power of negative, any number, even if it's infinity, then this whole thing is going to converge. It's going to converge to 0. It's going to become smaller and smaller. So under these conditions that a is less than s, this thing becomes 0. And then minus that one is going to become 1 over a minus s. Right, this is very important. So it means that the inverse Laplace transform of e a of t, the inverse Laplace transform, the Laplace transform, not the inverse, is going to be negative 1 over a minus s. Right, so that's the Laplace transform for this e is equals to a and t. Also, if you were to do this thing for, if I try to find the Laplace transform for e negative a of t, you're going to find that it's actually going to become 1 over, because remember, here it's you're going to have negative, you're going to have a negative, so it's going to usually going to become a minus s or a plus s. If you were to do the same procedure but then for this one, then you find that this is what you gonna get. So that's basically it when it comes to Laplace. This thing you can write it as 1 over s minus a, like that. So this is the Laplace transforms. So this becomes very important when now you have to change differential equations from the time domain into the Laplace domain. So we're going to do an example of how we change from the Laplace from the time domain to Laplace domain, and why this is important, especially when it comes to process control problems.